Hello, I'm Christine. In today's lab, I'm gonna isolate caffeine from tea leaves with the technique of solid liquid extraction and liquid extraction. I also use a new technique called salination, which will be further purify the caffeine I obtain. So now, why people are so in love with caffeine? Because caffeine is an important stimulant in tea leaves. Caffeine can stimulate nervous system, heart, and it also can cause the relaxation of respiratory and cardiac muscles. Caffeine can also withdraw symptoms like headache, nervous. Because of the caffeine, that's why people so love tea and coffee. So now today I'm gonna make a small but really strong cup of tea and extract the caffeine from it. This experiment has three main steps. The first step is to extract the water-soluble substance, which is the tannins and caffeine in the tea leaves, by using hot water. So we get rid of those insoluble substance, which is the solid, from the tea. This is called a solid liquid extraction. The second step is to extract the caffeine from the mixture by using the organic solvent dichloromethane. The tannins was then deprotonated with the use of sodium carbonate and converted into tannin salts. Tannin salts is soluble in water layer, but it is not soluble in dichloromethane. So that's how we can extract only the caffeine out from the mixture. We call this a liquid extraction. The last step is to purify the extracted caffeine with a new technique. We call it salination. At the end of the lab, melting point and RF spectroscopy was measured. So what we need to perform this experiment? First, we need a hot plate. We also need a 100 milliliter round bottom flask, a condenser. So the condenser was used to make tea because when you are boiling the water, some of the water will be evaporate really quick. The condenser helps to condense the water vapor and brings back the water into the flask. That's how we make the tea. We also need a separator funnel, pipettes, e-flask, graduate cylinder, and a centrifuge tube. And we also need a melt temp and IR spectrometer. Okay, so now what chemicals we use in this experiment? Of course, we're gonna extract caffeine out from the tea leaves, so here is the structure of a caffeine. We also need to use sodium carbonate. Sodium carbonate is really important in this experiment because it deprotonates the tannins from the tea leaves and makes it soluble in water but insoluble in dichloromethane. That's how we get rid of the tannins from the caffeine. We also need dichloromethane. Dichloromethane is used to extract caffeine out from the mixture. So at the end is the sodium sulfate. We know that sodium sulfate can absorb water from the dichloromethane. So now we can make the dichloromethane extract into a dry dichloromethane extract. Okay, so in the first step is solid liquid extraction. In this extraction, using the differences in the solubility of caffeine in hot water, I extract the tannins and caffeine from the tea leaves. Because we know that the solubility of the caffeine in water in room temperature is 22 milligram per milliliter, but in boiling water, caffeine has a much higher solubility. So now by boiling the tea leaves with the hot plate, we have tannins, caffeine, and water in the extract. After that, the hot solution was allowed to cool down to room temperature. So now we have the caffeine and tannins and water in the mixture. Next step is in liquid extraction. We know caffeine is more soluble in dichloromethane them in the water at room temperature. And also, dichloromethane is not soluble in water. We can go ahead and use this organic solvent to extract caffeine from the mixture by using this separatory funnel. We can see that the upper layer, the black liquid, was the tea, and then the bottom layer is the dichloromethane. However, the tannins are also soluble in the dichloromethane, but we want the tannin stay in the water layer. So we can do that by using sodium. So tannins are phenols. They are soluble in dichloromethane. Once they react with sodium carbonate, they will become phenolic anions. Phenolic anions is insoluble in dichloromethane, but is insoluble in water. So sodium carbonate was added to the water and dissolved before I added the tea leaves to the round bottom flask. Use the dichloromethane. Go ahead to repeat the extraction a few more times and collect the organic layer at the bottom in a tear flask. Before that, I measure the mass of the flask before I collect the extra, because I'm gonna use the mass of the flask to find out the mass of the crude caffeine. So after the few more extraction, I use sodium sulfate to absorb any water left in the extra. I use a pipette filter with cotton to filter out the sodium sulfate. After that, I use dichloromethane again to rinse the remaining sodium sulfate to ensure the complete transfer of all the caffeine. At the end, I evaporate dichloromethane in a water bath. I measure the mass of the crude caffeine by using the mass of the crude caffeine and then the mass of the flask, subtracting the mass of the flask. So now it comes to the salination of the crude caffeine. The salination further purifies the caffeine. We know that salination requires high temperature and low pressure. This can be performed with a vacuum. While heating the crude caffeine, use a Bunsen burner. The centrifuge tube filled with the ice can then solidify the caffeine on the bottom end of the tube. After that, allow the apparatus to cool down to room temperature, and then I carefully remove the caffeine from the tube to measure the mass of the purified caffeine. Now it comes to measuring the melting point. Since the sublimation point of the caffeine is lower than the melting point, so I seal the capillary tube by flamming the open end of the tube using a Bunsen burner, and then I take the melting point of the caffeine I got with the melton. I also get an IR spectrum of the caffeine I obtained. My result comes out is the mass of tea leaf I used at the beginning of the lab was 1.44 grams. The mass of the crude caffeine I got in the middle of the lab is 0.0207 grams. At the end of the lab, the purified caffeine I got is 0.0098 grams. A percent recovery of 0.68% was calculated, and the melting temperature I got for the caffeine is 228 to 233 degrees Celsius, which is pretty close to the normal melting point of caffeine, which is 238 degrees Celsius. One of the avoidable errors would be that I didn't squeeze out all the tea from the tea leaves. So there was still some of the tea mixture left in the tea, and also some of them were on the filter paper. There was also an avoidable error. It would come from that not all the caffeine was fully extracted by dichloromethane, because there's still some left in the water layer. This can all cause the mass of caffeine I got lower than the actual amount of caffeine from the same amount of tea leaves. Overall, I was able to extract caffeine from the tea leaves. I also learned a new technique called sublimation with the use of a vacuum and burner. Actually, this is a really fun lab in this semester. That's all. Thank you.